Hello everyone, and welcome back to the channel. Today, we're diving deep into one of the most terrifying chapters of human history, the Black Death. When you hear that name, what comes to mind? Probably rats, fleas, and a disease that wiped out nearly half of Europe. For centuries, that's been the story we've all been told. But what if we told you that story is incomplete, and maybe even wrong? In this video, we're going to uncover the true history of the Black Death and explore the groundbreaking scientific discoveries that are rewriting our understanding of what really happened. So, grab a seat, because this is a story of mystery, medieval horror, and modern science. Let's start with the classic tale. The year is ke-1347. A fleet of Genoese trading ships arrives in Sicily, having fled the besieged city of Caffa on the Black Sea. But they brought more than just cargo. On board were sailors dying of a mysterious illness, their bodies covered in black boils, or buboes, which gave the disease its name, the Black Death. From this entry point, the plague spread like wildfire across Europe. By 1351, it had killed an estimated 25 million people, a staggering number. The traditional narrative blames a bacterium called Yersinia pestis. The story goes that this bacterium lived in fleas, which in turn lived on black rats. These rats hitched lives on merchant ships, spreading the infected fleas to every port they visited. When the fleas bit humans, they transmitted the disease. And the rest is history. It's a neat, tidy explanation, and for a long time, it was the only one we had. It made sense, and it painted a clear picture of rats as the villains of the story. But as historians and scientists started digging deeper, they found some major holes in this theory. For one, the speed at which the Black Death spread was astonishing, far faster than what we'd expect from a rat-borne disease. The plague traveled overland during winter in places like Scandinavia, where rats and fleas would have been largely inactive due to the cold. How could it move so quickly through freezing temperatures? Furthermore, eyewitness accounts from the 14th century describe symptoms that don't perfectly align with the modern bubonic plague we know today. While the buboes were a hallmark, many chroniclers also reported severe respiratory symptoms, suggesting the disease was spreading directly from person to person through the air. This person-to-person, or pneumonic, transmission would explain the terrifying speed of the outbreak much better than the slow-moving rat and flea model. Another piece of the puzzle that didn't fit was the lack of evidence for a massive rat die-off. In modern plague outbreaks, a huge number of rats usually die before the disease spills over into the human population. You'd expect to find vast quantities of rat skeletons in archaeological digs from the 14th century. But we don't. Archaeologists have excavated countless sites from the Black Death era, and the evidence for a widespread rat epizootic, as it's called, is surprisingly scarce. This led some researchers to ask a bold question: were rats really the main culprits, or were they just scapegoats in a much more complex story? Some even proposed alternative theories, suggesting the Black Death might have been caused by a different pathogen altogether, like a hemorrhagic fever virus similar to Ebola. These theories were controversial, but they highlighted the serious doubts surrounding the traditional rat-flea-human model. For decades, this debate raged on. We had historical accounts, we had archaeological findings, but we lacked the smoking gun. That all changed with the advent of modern genetics and a field called paleogenomics. This incredible technology allows scientists to extract and analyze ancient DNA from the remains of long-dead organisms. In the early 2010s, researchers got their hands on a game-changing source of evidence: skeletons from a Black Death mass grave in London. They carefully drilled into the teeth of these victims, because the tooth pulp is a protected environment where traces of ancient pathogens can survive for centuries. What they found inside was revolutionary. They successfully isolated fragments of DNA, and when they sequenced it, they got a definitive match. The culprit was, without a doubt, Yersinia pestis. So, the traditional theory was lied all along. Well, yes and no more. The DNA evidence confirmed that Yersinia pestis was the killer, but it also opened up a whole new set of questions. The genetic sequence of the 14th century plague was different from the strains circulating today. This ancient version might have been more virulent, more adaptable, or capable of spreading in ways that modern strains can't. This discovery reconciled the historical evidence with the microbiological reality. It confirmed the pathogen but also validated the observations of medieval chroniclers about the disease's incredible speed and person-to-person spread. The Black Death wasn't just bubonic plague, it was likely a devastating combination of bubonic, pneumonic, and possibly septicemic plague, all hitting Europe at once. The story gets even more interesting. Scientists didn't just stop at identifying the pathogen, they began to trace its family tree. By comparing the DNA from the London victims with samples from other plague pits across Europe and Asia, they could build a genetic timeline. This research pointed to an origin for the Black Death not in China, as long thought, but in Central Asia, specifically in the Tian Shan Mountains of modern-day Kyrgyzstan. Sir, In a 14th century Nestorian Christian cemetery near Lake Isikul, researchers found tombstones from 1338 and 1339 that explicitly mentioned despite pestilence. DNA analysis of the bodies buried revealed a strain of Yersinia pestis that is the direct ancestor of the one that caused the Black Death in Europe a few years later. This was the Big Bang of the plague, the origin point from which the pandemic exploded. So what does this all mean for our understanding of the Black Death? It means the true story is far more complex and fascinating than just rats on a ship. We now know that the Black Death was caused by a specific, ancient strain of Yersinia pestis that likely originated in Central Asia. This strain was so successful because it wasn't just relying on rats and fleas, it was also spreading directly between people through coughing and breathing, causing the deadly pneumonic form of the disease. This explains the terrifying speed and its ability to spread even in winter. It seems that the primary vectors were not rats, but humans themselves, and instead of rats, recent research suggests that another rodent, the giant gerbil found in Central Asia, may have been the original long-term reservoir for the bacterium. Climate fluctuations in Asia could have caused these gerbil populations to boom and bust, pushing the plague outwards along trade routes like the Silk Road. This revised history doesn't just satisfy our curiosity, it holds important lessons for us today. The Black Death was a perfect storm of a novel pathogen, globalized trade networks, and populations with no more prior immunity. It shows how quickly any disease can emerge and spread, and it underscores the importance of a multifaceted approach to understanding pandemics. We need to combine history, archaeology, and cutting-edge genetics to get the full picture. The mystery of the Black Death is a powerful reminder of our vulnerability to infectious diseases, and how the pest, even the very distant pest, can hold the keys to protecting our future. So, the next time you hear about the Black Death, remember that the story is so much more than just rats and fleas. It's a gripping scientific detective story that took centuries to solve, spanning from medieval chronicles to modern DNA labs. The true culprits were a highly adaptable bacterium and, ultimately, the interconnected human world that allowed it to flourish. What do you think about this revised history? Does it change how you see this monumental event? Let me know your thoughts in the comments below. And if you enjoyed this deep dive into history and science, make sure to hit the like button and subscribe for more videos just like this. Thanks for watching, and I'll see you in the next one.